Hi everyone, my name is Maozheng Zhao, a PhD student from Stony Brook University, supervised by Professor Xiaojun Bi. This work is in collaboration with Shuming Zhai from Google. In this paper, we designed and implemented a voice and touch-based, error-tolerant, multimodal text editing and correction system for smartphones. We call this system VT. Changing text input, such as editing text and correcting errors, is a core activity we perform daily on smartphones. However, it is difficult to perform. The bottleneck lies in the need for precise and repetitive manual control. In this paper, we propose VT, which only requires users to tap the approximate text location and speak the correction content or the editing command. VT can automatically infer the exact text location based on the voice and touch input and the text context. This is a demo of using VT to edit and correct text. Attach the document. Cut this paragraph. Paste. Bold. Highlight this sentence. Your assistance. VT can accommodate ambiguity and uncertainty in text correction. In this demo, the user will insert the word better to the editing sentence. The user does not need to put the cursor exactly between the two words. He just needs to tap any of the two words adjacent to the insertion location, then speak the inserting word. Better. The user can say some context words around the insertion word to help to locate the insertion location. Some better news. In this demo, the user substitutes the two error words with "it was." The user does not need to precisely select the error phrase. He just needs to tap the phrase or the word adjacent to the phrase, then speak the new phrase. It was. The user can also speak some context words around the substitution phrase. It was very. VT supports word level, sentence level, and paragraph level text editing. Cut 2 paragraphs. Paste. Underline this sentence. Highlight 3 words. Highlight. Bold. Highlight. Next, I will introduce the workflow of VT. With touch input T and voice input S, if the voice input starts with one of the editing keywords, the inputs will be used for text editing, otherwise they will be used for text correction. For text correction, the first step is to generate correcting candidates. For example, the user tried to correct this sentence to "When do you have to be there?" The user tapped the mistyped word and spoke "Do you have?" VT will generate 3 kinds of candidates: insertion only, substitution only, insertion and substitution candidates. The second step is to compute the score for each candidate. The scores are computed based on a trigram language model, word embedding similarity, editing distance, and the location of the new phrase. The third step is to generate suggestions based on the combination of those scores. In this example, this sentence is the top suggestion. It is the user's correction intention. When do you have to be there? The top suggestion will directly replace the original sentence in the text view. The second and third suggestions will be shown as alternatives. For text editing, there are two modes, single command mode and compound command mode. Underline. Underline this sentence. We did two user studies to compare VT with the existing techniques. The first user study is to compare the performance of VT with the touch-only method. In touch-only condition, users used existing touch-based method in Android OS. In the VT condition, users can use VT method or touch-only method. This is because VT is proposed to augment rather than replace the touch-only method. Here are the results. This is the task completion time for text editing and correction. VT reduced about 30% time for both text editing and correction. We did another user study to compare VT with iOS voice control, which is an existing voice and touch-based method on iPhone. For text correction, VT reduced around 48% time from iOS voice control. For text editing, VT reduced around 30% time. To investigate where VT saved time, we divided the task completion time into two parts: text selecting time and text changing time. We can see that VT mainly reduced the text selection time. This is because VT does not require precise text selection. It will infer the actual location based on the input and text context. Conclusion. First, we have designed and implemented a voice and touch-based, error-tolerant, multimodal text editing and correction system for smartphones. Second, VT can accommodate ambiguity and uncertainty in text editing and correction. Third, VT greatly improves the performance of text editing and correction over the touch-only method and the iOS voice control method. This is a demo of using VT to edit and correct text. Attach the document. Cut this paragraph. Paste. Bold. Highlight this sentence. Your assistance. Thank you for your attention.